Welcome to Sustainability in Your Ear. I'm Mitch Ratcliffe, your host, and today we're pleased to be joined by Ray Lam, who is the founder and president of Silk Road Solar, which is part of Silk Road Environmental, a Chehalis, Washington company that sells and designs solar water heating systems across the United States. Ray, thanks very much for joining us on Sustainability in Your Ear. How are you today?
I'm wonderful, and it's a pleasure to be here. Thank you very much.
Now, I understand you're working from your office today. Tell us about your office today.
My office is a cab of my pickup truck. I'm sitting outside of a built urban, passive design multifamily that they're putting up in Seattle, and it's got 17 solar hot water heaters installed to supply most of the domestic hot water needs of this multifamily complex in Seattle.
Oh, that's a great view that you've got there. So tell me now, solar water heating has been around for 30 years or so. I can remember it from back in the 80s. But I also remember back then you didn't necessarily know whether you would get scalding hot water or cold water. You've developed technologies that help to manage the heat throughout the day and essentially store that energy. So how has solar water heating evolved over the past 30 years? And tell us about your specific innovations.
I think there's been some huge innovations over the last few years. Primarily, the first one is, of course, digital control. The control strategies and the computers available are a lot smarter than they used to be in the 70s and 80s. The next big change for the Seattle area is people have moved from flat plate solar hot water heaters, which were the lowest cost models back in the 70s and 80s, and switched over to vacuum tube systems, which are better performing in the winter. The flat plates are great in the summer or in California or Arizona, where you get a lot of hot temperature all year round. But when the ambient temperature drops below the liquid temperature on a flat plate, you lose temperature. So typically you would hear people with the old system saying they work great in the summer, but we don't get anything in the winter. Vacuum tubes work pretty much independent of ambient temperature. So winter or summer, they work pretty much the same if it's sunny. However, one of the big changes that have happened in the last 7 or 8 years are something called triple target tubes, and they're tuned specifically for ultraviolet, and they allow these systems to work at 70% of the normal capacity, even when it's completely gray and overcast, like we get in the winters in Seattle out here.
So that it's no longer something that you should think of purely as a warm weather or warm climate type of technology. It's something that can work anywhere. And the ultraviolet's fascinating. I hadn't really thought about the fact that you capture heat from the non-visible light. So tell us about the thermal fluid. I know that's how you're moving the heat from where it's being collected to where the water is being heated. How does that work?
Yeah, some of the older systems used to either use water as the fluid to strip the heat, or propylene glycol or ethylene glycol, primarily propylene glycol. And those systems had the advantage where if you lost power in the winter, your system didn't freeze up as it would if it was a water-based system. The problem with those systems is that if you lose power in the summer, they would often vent. That is, the flat plate or evacuated tube, they got really hot, and the glycol would turn to steam, and then the system would fail to operate anymore. On water-based systems, same thing. The water would boil, system would go to steam, and then you would sometimes have to go out and monkey around with the system. And also on what we call mismatch loads, where you're heating a bunch of stuff in one season, but you're not using the solar hot water system in other seasons. And examples of that would be swimming pools. You only heat them in the summer, not in the winter, or raised floor or baseboard heating, where you heat them in the winter, but then you don't heat them in the summer. And in those cases, you would have too much heat, and people would have to put blowers or baseboard heaters or other weird things to get rid of the heat. The thermal fluid allows it freezes at -40 and boils above the maximum temperature that the vacuum tubes can reach, which is about 450 degrees Fahrenheit. And so they allow for two things. The same thing, if you lose power in the winter, you have freeze protection. But in the upper temperature range, since it no longer boils, when your tank or pool or radiant floor system hits the desired tank temperature, it allows the thermal fluid circulation to stop, which gives you much more precise temperature control. A good example is one of the multifamilies we put up for the same builder in Seattle just a few months ago. They've got one solar hot water system for domestic hot water, one solar hot water system for building heat. And the building heat system basically sits unused most of the summer.
So this is interesting. We started talking about heating water, but you're really talking about distributing heat throughout the house, whether it's to a pool or a system in the floor to keep the room warm.
Yeah, the solar hot water systems have really branched out as people have realized it's not the solar hot water portion is a little bit misleading. So we've got companies like Solar Spirit. It's the first vodka distillery in Washington State that solely uses solar hot water systems to produce their vodka. We've got companies like Sweet Bee Honey that are using the solar hot water system to heat their radiant floor with frames of honey to keep the viscosity consistent when they harvest the honey. We've got places that are blowing hot air into their warehouses and stuff to keep their warehousing warm, like Hamilton Cellars, which is a net zero winery in the state. So for a lot more of applications for hot water than just domestic hot water. In fact, we've got a project with Mount Rainier, the parks there, to heat their sewage and composting operations in the winter using a solar thermal system, because normally in the winter it's too cold for the bugs, the microbes, and in this case, now that we're able to keep it 70, 80 degrees even in the winter, they can start to try out vermiculture, the earthworms, which would normally be basically inactive in the winter.
And that's amazing, because there is a ton of snow at Mount Rainier in the wintertime, and this still is working.
Yeah. The other big thing that's happened in the last few years for solar thermal, especially in the Pacific Northwest where we've operated, is the cost. We have adopted a high volume, low margin model, and that's allowed the solar hot water systems to drop in install cost by about 80%. So our typical installed solar hot water system for water-based is about $3,200 before any incentives. For a thermal fluid system, it's about $4,500. And we're a vertically integrated manufacturer, which means we are happy to sell do-it-yourselfers just the parts if they want to do it themselves. And so if you're doing a do-it-yourself job, typically you're looking at $2,200 a part, which is the controller, the thermal hose, which we use a 304 insulated stainless hosing, the tanks and the solar collectors. That's all before the 30% tax credit.
So it's becoming less expensive. There are credits, obviously, and you get the satisfaction of not paying for heating your water, as well as the environmental benefits.
Some of the stranger applications you might see are, we've had some people in Lacey, they used 190-degree hot water as a herbicide pesticide. They kill all the weeds in their driveways and stuff, claiming they like it because there's no residual for pets and animals and kids right after the application.
So, and we were talking before we started recording about the fact that this is a system that you can upgrade over time too. So if you're a do-it-yourselfer or you have this installed, once it's in, you can continue to make improvements by adding new components that will improve the overall performance. So it's a little like hacking in the computer world. You put together your own solution and you continue to evolve it. How does
Absolutely, especially for people that might want to upgrade an existing or an old system, the costs are much lower because you don't have to rerun pipe and stuff because it's already all in place, and they're usually pretty compatible with what they already have.
So is there a cost involved in customizing the system to a particular installation?
We normally do the design work for the clients at no cost. It's one of the problems we have at Silk Road is we're too geeky for our own good. So it's always interesting for me to work with the clients to see what they might be missing. So we just did one in Wenatchee this weekend, and their initial one was just to install a 8-panel system to heat their swimming pool. But what we were able to do, talking to them, was also heat up their building. They didn't realize they could blow hot air. So we use a hydronic heater from King Electric, your manufacturer here in Seattle, to blow 200-degree air into the building in the winter to keep the rest of the pool equipment from freezing.
Oh, that's amazing. So let me ask, Ray, how did you get into the solar business? This obviously is a passion of yours. What drove you to jump in?
I originally started this company on my 45th birthday. It's sort of a midlife crisis of I was a environmental and technical manager for a big pulp and paper company in Washington State, and just wanted to do something that was a little bit more environmentally satisfying for me. So I started a consulting business to focus on environmental footprint reduction. That is, instead of shifting waste and emissions around, you would look at a holistic view of the facility and make sure that you weren't transferring waste from one place to the other, from air to water or from water to solid waste. And one of my clients was looking at reducing their CO2 footprint, and they had mentioned solar hot water as a way of reducing their, it was a fertilizer plant in Pasco, Washington, that was using propane to heat their fertilizer process water. We got a quote, and it was really high, like $45,000 for 3 panels to be installed. And at that point, we just said, well, there's no payback if you're looking at return on investment to switch over. But later that year, I was doing another project. I was flying out of China, and absentmindedly, kind of glanced down and saw, all these solar hot water heaters as I was flying out. And I suddenly realized that I said, the cost shouldn't normally be this high because these guys don't make that much money per year, yet, a lot of the houses have solar hot water systems on it. And that's when I realized that, it was a low volume, high margin business model in the state. And we just set out to specifically provide green solutions to the middle income and lower third income people, which were largely being ignored.
Well, Ray, this is fascinating, and everybody should check out Silk Road Solar. You can see it at silkroadenvironmental.com. And we'll, of course, have a link in the accompanying art of this podcast. Ray, thanks very much for taking some time to talk with sustainability in your ear today.
I thank you very much for inviting me. I look forward to hearing from some of your listeners.
Well, that's it for the interview. Folks, stay with us. We'll be back with the next show. This is Sustainability in Your Ear, and I'm Mitch Ratcliffe.